Hello everyone, this is Mr. here once again, and this lesson will be Notes 1-1 part 3. Okay, so before we get started, I'm just going to point something out. Okay, so don't forget domain goes from left to right, and range, which is the Y values, go from bottom to top. Okay, and if you understand this, that's going to make this lesson a lot easier and faster for you to understand. So I'm going to use left to right. Okay, so I'm looking for domain. So here I'm being asked to find the domain and range of each graph in set builder and interval notation and determine if it is a function. So first of all, I'm going to go from left to right. And on the left, I see that I have an open circle. So I'm going to draw with my blue highlighter. Okay. I'm going to draw a dashed line. And then on the right, I see that I have a closed circle. So I'm going to draw a solid line. And that's going to help me determine the domain and the range and what I need to use to state domain and range. So let's go ahead and do the domain first. So domain, notice that on the left, the value of x is -1 and -2. Okay, so that means I'm going to have a -2. Okay, that's going to be the inequality for now. It's going to be less than, and then we have an x here. Okay, and then what's the going to the right? What's the value of x? So in this case, it's 1, 2, 3. So x is less than 3. But this one is a closed circle, so that means it's also equal to. This one is an open circle, so it's not equal to. Now, the part that you got from the previous lesson is we added this. We said we used the braces, so x such that -2 is less than x, which is less than or equal to 3, and then close the braces. Okay, so this is how you would state the domain in set builder notation. The next one is for interval. Notice again, from the left you have a -2, so always start from the left. So it's going to be -2, and then from the right you get to 3. But -2 is it's an open circle, so this one gets a parentheses, and this one is a closed circle, so this one gets a bracket. Okay, now let's go on to the range. The range, what I'm going to do is I'm going to use this. I don't have red, okay, but I'm going to use this marker here or highlighter, and it's going to be a dashed line because it's an open circle. But this one here is going to get a solid line because it's a closed circle. So now that's going to help me with the range. So looking at the range from bottom to top, you always start from bottom to top. So what's the lowest value of y? So in this case, y is -1, 2, 3, 4, and 5. So y is going to be -5 here. Okay, less than y, which is less than, and the highest value, okay, the top of this one is 1, 2, 3, 4, 5. So this is 5. Now let's look at the circles. This one is open, so this is just less than, strictly less than. This one is closed, so this one is going to be equal to. Okay, now let's add again the what you learned yesterday. So I'm going to open the brace, and this will be y such that y is -5 is less than y, which is less than or equal to 5. Okay, now what about interval notation? So for this one, again, start from the bottom. The bottom is -5. And keep in mind, it's an open circle, so this one gets a parentheses. And then the top is a 5. That's the highest this graph is going to go, and it's closed, so this one gets a bracket. The last question is this a function? So from the vertical line test, if I draw a vertical line through any point on this graph, it's not going to cross the graph at no more than 1 point. So the answer to this one is yes, it is a function. Okay, so it's the graph of a function. Let's go on to the next problem. So number 3. Again, let's look at this graph and let's start with domain. Don't forget, domain is always, you always start from left to right. So I see from left to right, I see that this is a solid circle. Okay, I'm sorry. This is a closed circle, so I'm going to give this one a solid line. Now, as it goes to the right, where is it going? Okay, that's the question. Where is it going to the right? So in this case, this arrow is saying that it's not going to stop. So this one goes to positive infinity. Okay, so keep that in mind because that's going to come in handy when we state the domain. So for domain, see what happens. So domain is going to be, and I'm going to do the brace here. It's going to be x such that, what about x? So notice we start from -1, -2, -3, and -4. Okay, so we know we get from -4, but from here, this goes strictly to the right. So the question is, how do we state that domain? And you do it in the following way. So I'm going to have x, okay, and since it's going from -4 to the right, meaning it's going to take from -4 and it's not going to stop. So from -4, I'm going to take all the values that are greater than or equal to -4. Why equal to? Because this one here is it's an open circle. Okay, so let's do for interval. So for interval on the left, again, we start with the farthest to the left, so this will be -4, and this one is a closed circle, so it gets a bracket, but to the right it goes on to positive infinity, and this one gets a parentheses. Okay, and what about the range? Again, for the range, I'm going to use, so this one, again, don't forget, you go from bottom to top. So it does hit that point, okay? But after it hits that point, it goes straight up, and it's not going to stop, and this arrow is telling you what's going to happen. So for the range, this goes to positive infinity. Okay, so don't get confused between this point and that point. This is the lowest point, so this is the bottom, and the highest we don't know. It's just saying I have an arrow, I'm not going to stop. So to state the range in set builder notation, again, this will be y such that y, what is y doing? Okay, it hits this value, which is the lowest. So this is the bottom is 0, hits 0, and then bounces, okay, and goes up. So y such that y is greater than 0, but since it hits that value there, it's also equal to. Okay, now for the range in interval notation, so again, we have 0, and this one does, count this as a closed circle, okay, so this will be a bracket, and then it goes on to positive infinity, so then this one gets a parentheses. Last question is this the graph of a function, and again, this one passes the vertical line test. If you draw any line, it's going to pass that that test, okay, so this one is a function. All right, let's go on to the next example. Okay, on this one here, again, start with the left, farthest to the left for domain, and don't get confused between domain and range. Okay, they're not the same thing. So farthest to the left, we see that this has an arrow, so that means it's going to continue going. And I know you get confused here. You might think, well, it's going to continue going down, but right now we're talking about domains, which are the x values. So it's going to continue going to the left. Is it ever going to stop going right? Yeah, we have a closed circle here, so I'm going to draw a solid line. But when it comes to this side of the graph, this one is not going to stop. It's going to continue onto negative infinity. Okay, and this is going to help me to state the domain. So let's do this in set interval notation first. So x such that, and what is x doing here? Okay, so watch. So x is going to, this is 1, 2, 3, 4. So what's x going to do from 4? What's going to happen to the domain? It goes to the left. So this will be less than 4 because the graph is going to the left from 4. Is it equal to? Yes, it's a closed circle. Okay, so this will be the domain in set builder notation. Now, in interval notation, you would say, look again, the left. Okay, on the left, this is going to negative infinity. Okay, and on the right, this is going to get to 4. But negative infinity, whenever you have infinity, you will always have parentheses. And this is a closed circle, so this one gets a bracket. All right, let's go on to the range. The range, okay, again, bottom to top, but this one is saying I'm not going to stop going down. Okay, so that means this one is going to negative infinity for the range. But what about the top? Notice that it gets to this point, and then what does it do? It bounces, but it doesn't go below that point. So the point is, this will be our max, and I'm also going to give this one a solid line because this point is being used, that value for why it's being used. And the question is, what is that value? So the value there is 1, 2, 3, and 4. So the range is going to be y such that y, okay, what's happening here? We know it gets to 4, but from 4 it goes down, right? So it's going to be less than or equal to 4. Why equal to? Because that point is on the graph. Okay. All right. So the range in interval, again, bottom to top, we know from the bottom we have negative infinity, and the top, that's going to be a 4. The 4 gets a bracket because that's a point that's being used, and this one gets a parenthesis. Last question for this one is this the graph of a function? And the answer is yes, it passes the vertical line test, and you can try it as many times as you want, and you'll see that this is a function. Okay, so on these next two problems, and I'm only going to do one of them. Okay, now I'm gonna let you guys do the evens. So I'm doing the odds, I'll let you guys do the evens. So on this last example, an asymptote is something that you saw in Algebra 1. Okay, you might have forgotten, but I think you'll remember this once I go over this example. So an asymptote is a line that a graph approaches as x or y increases. Okay, so example, find the domain and range of each graph in set builder and interval notation, then determine if the graph is a function. Now, this line you see here, this dotted line, that's called an asymptote. So as you can see, this graph is approaching that line and it's getting as close as it possibly can, but it's not going to cross that line and it's not going to touch that line. So that line is what we call an asymptote in algebra, okay, or in math. So I'm going to state again in set builder notation the domain and the range, and I'm also going to do it on interval. And I'm going to use my colors if at all possible. So if I'm doing for domain, if you look at this graph, is it ever going to stop going left? Remember, we always go from left to right. Is it ever going to stop going left? I'm asking. You see the arrow? That means no, right? It's not going to stop going left. Well, let's go to the right. Is it ever going to stop going right? Well, based on the arrow, it's not going to stop going right. So that means I can't bound this graph. There is no starting point. There is no ending point. This just goes on to negative infinity to the left and positive infinity to the right. And again, don't get confused. When it comes to domain, you're not looking at this graph if it's going up or down. So for domain, I'm going to come back from lesson 1, I believe. Okay, from video 1, x such that, okay, this means that you are going to use all real numbers. So remember that e or epsilon and this symbol, okay, where this symbol means all real numbers, okay, and this is how you would state the domain for this graph. And that's in set builder notation. Now for interval, this goes to negative infinity to the left and positive infinity to the right. Let's go to the range now. So for the range, as you can see, based on the asymptote is saying you can approach this value for y in this case, but you cannot cross this value. You can get as close as you want, but you can't touch or cross. Okay, so then the question is, what is the value of y at any point on this line? And the answer is -1. So let's see how we would state the range of this graph. So y such that we know we have a -1, but let's see what happens at -1. Okay, so from -1, from bottom to top, this gets, y increases, so it's getting bigger, so it's becoming a larger number, right? So then we say greater than. Can we say equal to? No, the asymptote doesn't allow for us to say equal to. Okay, so this will be the range in set notation. Now the range in interval notation, again, from the bottom, this is saying you will not touch -1, so it's going to be a parenthesis, -1, but to the top this continues, it's not going to stop. Okay, so it goes to positive infinity because of the arrow, and I didn't mention that here, but I hope you see it. Okay, the arrow says it's not going to stop, so it goes on to positive infinity. Now the last question is this a graph of a function? Well, you can do the vertical line spaghetti, which is what I have, vertical line test, and then if you see that it hits 2 points, then that means it's not a function, but it's not going to hit 2 points. So this is the graph of a function. So I'm gonna let you guys try the ones that I didn't do so you get some practice, okay? And I'll talk to you next time. Until the next time, and don't forget, if you have any questions, you can always get in touch with me via email, Remind, or Canvas messages, okay? I'll talk to you soon. Bye-bye.